I'm Nitesh Agrawal. I'm leading this structural design team here at Skeleton Consultants Private Limited, Noida. We are about 40 years old organization established in Indore, and then we had another office here in Noida, which is operating for last 20 years. We are into the steel construction and steel design engineering for last 10 to 15 years. And I'll just briefly showcase some of the good steel structures we have engineered. So we have done some housing projects for under PMAY for Government of India. One was at Lucknow, which was 13-story high. At Agartala, the high seismic zone. At Indore, it was a low-rise building. We have done the Triple IT Nagpur campus in steel. There was a Paradise Avenue project for a private builder at Jammu. Again, the high seismic zone. We have done some school buildings in Greater Noida in steel. These are some industrial. Then we have done one accommodation facility for MES at Delhi Kent, one hospital building at Ballabgarh, Haryana, one hotel building in steel Indore. We are currently doing this redevelopment work of Udaipur Railway. Basically deals with steel structure, so it's a huge and very beautiful steel structure. And the last one is very innovative and dome-shaped steel structure, which we have done at the Rakabganj Gurudwara, New Delhi. Apart from that, we are into this statue engineering, and the statue we again have the core as a steel framed structure. So this is some of the statues we have done. So I'll just start my presentation on how the steel will help in the mass housing sector. So right now, prevalent was the structural system which was used in industry was the masonry construction, which was good for low-rise buildings like 3-4 story. It was very old thing. It was somewhat non-engineered. Then the engineering practices start. We started going upward vertically. We started using certain machineries and tools and tackles, and reinforced concrete structure, framed structures started getting popularized. Then this industry shifted toward structural steel, and now the time has come where we are doing the structural steel frame buildings for the high-rise residential towers or the commercial buildings. And rightly said by the previous speaker that data center and other things which are being built in the steel, apart from the previously railway kind of buildings or the industrial shed-like structures. What are the limit? Why we are talking about pre-engineered is because it is off-site. And what are the limitations on on-site? Like RCC construction, they are very much dependent on weather. There are safety concerns because all working is happening on the site. Because of increased schedule, that delays and other things, and the productivity is low, and it is very much labor intensive, and availability of labor these days is very short. Again, like the wastage of material happens at site. In case of on-site construction, site becomes very clumsy, unclean. There are many kind of raw materials stored somewhere. There are certain places the excavation is done, so site is not that good to roam around. And there is a very acute point like wastage of water is happening. So these things we can somewhat overcome by switching to the off-site construction. In off-site construction, as we have seen from my previous three presenters also, that the building time is very short. And again, since most of the things are manufactured or produced off-site, so the risk of getting some damages or something is very low. Again, because we are making into controlled environment, our qualities are very much higher as compared to the in situ construction. We are into a factory, we are in the closed shelter working. So for labors or other things, we have improved the working environment. And again, if we talk about environment, we are reducing the impact on environment. Why? Because the waste is getting reduced. The emissions at this site is getting reduced, although there are emissions at the factories, but the factories are located way away from the city centers. So cities are not directly getting affected. the dust pollution, the air pollution, this is getting reduced. So what is happening in the current scenario is the world is changing, and so the construction sector should also change, because we have a demand of rapid urbanization. Climate is the urgency. We need to take care of the climate. We, over the last 50, 60 years, the technology has accelerated much. Now we are into AI sector, and which can definitely help in doing the construction of site. Our cities are expanding like anything. We are getting daily, we are hearing about some high rises building vertically. We are going up and up. We are following the west. Horizontally, also, our cities are expanding to the extensions of the cities. We have, because of the population of India, we have an urgent need of building the faster doing the faster constructions for homes. The homes must be smarter now, because the people have become technologically smart. And again, from the environment point, it needs to be greener. And traditional construction method, as I told before, there are slow, labor incentive, and resource dependent. So that's why we need the steel, and steel is that center of that transformation. In steel, if we talk about, steel was conventionally being used for last so many years, but in last 30 years, so pre-engineered steel has evolved. And now in 2026, we can see that people are much aware about the pre-engineered steel construction. So I'll just brief about what is the pre-engineered construction. Generally, what happens, we are designing, fabricating, and manufacturing everything on off-site, which was already told by Mr. Sudhir earlier. And other points are also, so the only thing, the last point is that complete planning, including the architecture finishes, structural frames, these are all done in advance. There are no changes later on at the construction site. So we have done everything in advance, just like Rishabh has said that we are doing everything in BIM. So all things, clashes and everything have been done in advance, so that we are reducing the construction time and last minute revisions on site using the pre-engineered construction. What steel helps in fulfilling the basic requirement of housing is, it provides the stability. Steel is very reliable material. It is strong as compared to the concrete or other materials. Steel also provides a high serviceability and durability to the structures. And again, if it is used in with good planning, it brings a good economy. It has a recyclable value, so it's economical to use. And again, with the steel, we can like our architectural friends like to have aesthetically good shapes, good facades, curves, structure. So this all can also be possible with the steel. So it's aesthetically also very good. So I'll just briefly go through the advantages what pre-engineered steel brings to the housing sector specifically. It reduces the construction time. Like in the case of housing, if we go with advanced planning, like it was identified by Rishabh, that if we do the advanced planning, if all the stakeholders, all the parties to the construction are are involved from the day one of the project, if it has been that perceived as a pre-engineered construction, if it has been thought of as that there will be a steel construction or a steel structure building, so that's why we can reduce the construction time. And because the steel is manufactured off site and it's just assembled at the site, we can allow for a faster occupancy to the occupants. We have a high quality control, so it reduces the maintenance and the other tasks later on for the buildings, which generally are very much required in the housing sector because of the water leakages and other environmental abuses. Next is the low maintenance, and last one is I talk about this pollution control and environmental sustainability. Since because the PEB is precisely cut, manufactured, and it reduces the material waste, dust emission, noise emission, air and pollutant emission is very much low, and it is majorly at the factory site, not at the site. So that's why we are providing a pollution control, and the material is environmentally sustainable. Also, steel is highly recyclable. So it has an initial cost, and then at the end we have a scrap value also. So that also helps in our steel construction. If we talk about pre-engineered steel structural system, currently we have two kind of a structural system, where in the one system we have hot rolled steel sections, and in the other system we can use the light gauge steel systems. I'll just briefly tell about them. So in hot rolled steel construction, we primarily use the open sections like I sections, or channels, or closed sections like circular hollow sections or square hollow sections like. And these sections replace the RCC column beams to the steel columns, steel beams. Even the staircases and other things can also be built using steel. So this is the hot rolled steel structure system. And there is one more system where we have light, very thin gauges steel materials, which are of the range of 0.75 mm thickness to 0.95 mm thickness to 1.5 or 1.7 mm thickness. These sections are very light, and these sections, just if you see the image in the presentation, the RCC building looks very bulky, and this light gauge frame structure looks very light. So this is again one more system which can help in the pre-engineering the building sector. Just at the start, which I have told that we have done few housings using steel. So I'm just briefing three projects of us which are under the PMAY scheme, where the government of India wanted to promote the use of steel, and these three projects were promoted as a live laboratory. That what the PM during the inauguration said, that these are the live laboratory projects, where we are using this steel, the new technologies, the new components, so that this we can understand what are the challenges, we can understand what are the drawbacks, and what are the places where we need the improvements. So we were fortunate enough to participate in three of such projects. First one was in Indore, which is comprises of 8 towers. The towers are the steel plus 8 floors. This was for the affordable housing scheme, and here we have used steel and concrete hybrid structural system, where the frames are in steel, and these shear walls in the service areas like staircases and lifts were provided in RCC to cater for the lateral forces due to earthquake and winds. Similar type was done for Lucknow, but the interesting part is this: the towers are 13 floor high, and Lucknow falls in the seismic zone 3. And again, one project was in Agartala. This site has a challenge of low soil bearing capacity. So RCC being bulkier was not thought of, and from the day one, steel was the only choice. There were 7 blocks, all were of 6 floors each, and Agartala is in the seismic zone 5. So you can understand, at the high seismic zone and at a site where there are low bearing capacity, high water table, steel is the only solution which can help in realizing that dream of making an housing project at such a location. This was the structural system which was followed in all these three projects. The construction photographs of these three projects are at the bottom. For the flooring, we have used a deck sheet, and over the deck sheet, nominal concrete slab was cast with reinforcement to take care of the stresses due to the gravity loads. Just like was talked about, that for softwares, we have utilized the ETABS software for accurately analyzing the loads and the patterns and the behavior of this building. We have done the seismic detailing as per the chapter 12 of IAS 800. And with this software, we were able to optimize the demand, and accordingly, we provided sections. And for the housing, what we did is we modularized these sections from first floor to second, second to terrace. We have used similar kind of sections so that it helps in uh, faster erection at the site. This is the major and most important point for steel structures, that connections should be dealt properly. And accordingly, we have prepared a very exhaustive drawings for fabricators and erectors to understand how the connections will happen. And the specifications of the bolts and other materials will clearly mention so that there is no uh, mix in the or the poor material is used. So what are the challenges we felt or we observed during such these projects? I'll just give a brief of those projects, the brief of those challenges. Unison with the all stakeholders. What happened is all the stakeholders. Let me explain all these points one by one. So unison with all the stakeholders. What happens in such a projects? Structural engineers, fabricators, erectors, they are not involved at the initial stages. So it happens that you're not able to conceive or perceive the project in steel. At the initial stage, we need to understand what is the material available at the supplier's end so that the design can happen accordingly. Next thing, the transporters, the erectors, we need to understand from them what are the allowances is required in design so that there are no damages or no distresses in the material during the transportation or erection. Basic concepts and perception, just like in the industry or in the academics, we are taught about the RCC construction. We are in the first stage. If we talk about a building, we perceive it as an RCC building only. We generally don't perceive it as a steel building. So that's the need of the hour, that we need to taught everyone that building needs to be perceived as a steel structure for
So
this kind.
sorry to interrupt, sir. We are running out of time, so can you?
I'll just finish in 2-3 minutes. So we need to think about masonry and walling options and the non-structural connection to the steel structures. Complex shapes and understanding of the behavior and visualization with the steel is much needed. We need to detail the connections to cater for the faster erection at the site. Detailing should be construction friendly. Shop drawings and beam drawings should be prepared, and so that there are no mistakes during the fabrication. Fabrication work should be taken care by very good quality fabricators. Uh, Specification should be specified very clearly so that there is no deviation because of absence or non-availability of the material. On-site welding should be avoided. Erection should be properly discussed during the initial sizing so that we can amend the member sizes and other thing as per the erection requirement. And maintenance for this, you should cover the connections and other finishes so that maintenance is easy to do. My last slide is about the way forward. Way forward for the housing, we need to create an awareness about the steel construction. A promotion to the steel uses is required, which industry, ISDA, BMTPC, other are doing. So that needs to be built to the bottom level. We need to impart training and skill development to the all. Interdisciplinary collaboration should happen between all the stakeholders. Seismic detailing is the need of the hour. 3D detailing using BIM, Tekla software is required. We need to with the providers, anti-corrosive treatments and fireproofing treatments for steel is needed, which are very costly. We should think about reducing the cost of this, and case studies of such projects should be published. So last, I'll just conclude that yes, we cannot replace concrete and steel, but we should aim to make the building's lifetime energy consumption small by bringing new, innovative, and sustainable technology. And it's a crucial time that we move towards the off-site construction to the modular construction using robotics, automation, and other things. Thank you. I understand I've taken a little bit higher time, but thank you for your patience.